All right, let's just jump right in. We are tackling, honestly, one of the most audacious ideas in all of science. It comes from Rudolf Schmidt, and it's this framework that tries to build a bridge between the physical world of stuff and the inner world of our own thoughts. Now, if he's even close to right, this could change, well, literally everything we think we know about what reality even is. I mean, just think about this for a second. What if there was a single set of rules, one single, elegant mathematical language that didn't just describe how a planet orbits a star, but also how you form a memory, how you make a choice, or even how you're experiencing being you right now? That is the absolutely massive, mind-bending question we're digging into today.
So, to really get why Schmidt's theory is such a big deal, we gotta look at the problem he's trying to solve. And honestly, it's a problem that's been around for hundreds of years. You see, for centuries, science has had this giant wall, this huge chasm running right down the middle of reality. It's basically split our understanding of the universe into two totally separate worlds that just don't talk to each other.
And yeah, this great divide goes way back. We're talking about the philosopher René Descartes. He's the one who basically drew the line in the sand. On one side, he said you've got res extensa. That's, well, it's just the world of physical stuff. All the matter, the energy, the things physics loves to measure. But then on the other side, you have res cogitans. And that's the world of the mind. Your thoughts, your feelings, your consciousness. And for hundreds of years, that's how it's been. Physics takes one side, cognitive science takes the other. And they've never really spoken the same language, mathematically speaking.
Okay, so now we get to building the bridge. And an idea this massive doesn't just pop out of thin air. Schmidt didn't come up with this in a vacuum. He was absolutely standing on the shoulders of giants. All through the 20th century, some of the most brilliant minds in science were leaving behind this trail of breadcrumbs, these little clues, all pointing to a reality that was way deeper, way more connected than that old divided picture. And I mean, what a legacy. You've got Niels Bohr, who was the first to show that, hey, the person doing the measuring, you can't actually separate them from the quantum system they're measuring. Then you get John von Neumann, who literally forged the mathematical link between physics and information. Then comes Carl Pribram with this totally wild idea that the brain might actually work like a hologram. And of course, Sir Roger Penrose, who's still hunting for real quantum stuff happening inside our own neurons. You see the pattern, right? Each one of them was laying down another plank on this bridge that could finally connect those two worlds. And this is where Rudolf Schmidt steps onto the scene. He takes all these clues and proposes a new foundation. And it's built on just three pretty elegant axioms. So number one, the movement axiom. Sounds simple, right? Physical things move, either in a straight line or a curve. Okay, number two, the cognition axiom. All our thoughts are based on information we get from the world around us. Makes sense. But then you get to the third one, the integration axiom. And this is the absolute game changer. It basically just declares that the physical world and the world of thought, they're not separate. Not at all. They're just two different faces of the very same unified reality.
And here's the crucial part. He didn't just say it. He wrote it down as a formula. Psi equals B tensor K. Okay, let's break that down. The psi represents the single unified reality. B is for physical movement. And K is for cognitive information. Now, that little symbol in the middle, the circle with the cross, that's a tensor product. And you can think of it as the mathematical magic key. It's what weaves these two seemingly separate worlds together into one single unified description.
All right, so we have this beautiful, really elegant theory on the table. But in science, being beautiful isn't enough. Not even close. An idea this big, this revolutionary, has to face the fire. It has to be tested, it has to be picked apart, it has to stand up to some really, really tough questions. And that brings us to the big but. Does an idea that looks this good on paper actually hold up to the messy, weird, and frankly, completely bizarre reality of the universe? Especially when you get down to the quantum level. And this is where physicists really start poking holes in that first simple axiom about movement. Because when you look at the quantum world, particles don't always travel along neat little paths. They do something called a quantum leap. They can literally just vanish from one spot and reappear in another
without traveling the space in between. Then you've got quantum non-locality, or what Einstein called spooky action at a distance. Two particles linked across the universe can instantly affect each other. There's no path there. And if you get near something like a black hole, the concept of a clear classical path it completely breaks down. Okay, so yeah, those are serious challenges, big ones. The puzzle is definitely not solved. But, and this is a big but, despite all these hurdles, the promise of a unified theory, the potential of it, is so huge that researchers are absolutely not giving up. They're pushing forward, trying to figure out what it would mean for us if we could actually crack this code.
And that brings us to this incredible quote from the great physicist John Archibald Wheeler. It from bit. 3 simple words that turn everything on its head. The it is the physical world. It's the chair you're sitting on, the air you're breathing. The bit is information. What Wheeler was suggesting, and what Schmidt's theory really runs with, is that at the most fundamental level, the universe isn't made of stuff. It's made of information. The physical world arises from information.
So what could a unified theory like this actually unlock? Well, the possibilities are just staggering. Think about it. Quantum computers that don't just calculate, but actually mimic human thought. Brain-computer interfaces that are perfectly seamless, not because we've gotten good at translating, but because the brain and the machine are finally speaking the same native language. We could be looking at medical therapies that treat the brain on a fundamental quantum level. It's not just a new chapter, it's a whole new playbook for technology and for reality itself. And look, this isn't just some sci-fi pipe dream. This is happening now. To actually test these wild ideas, theorists are building some seriously powerful new tools. One of them is being called the quantum tesseract. Now think of it like a super advanced virtual laboratory. It's a computer model designed to simulate and visualize what these unified mind-matter realities would even look like, how they'd behave. This is how you take the first step from a wild theory to maybe, just maybe, building real technology from it.
So we're building to the final question here, because ultimately all of this, the axioms, the mind-bending applications, this whole it from bit idea, it's all building toward a single ultimate goal, finding one single equation, the math at the very heart of reality. And here it is, the proposed grand synthesis, the quantum gravitations formula, or FQ for short. I mean, just look at what it's trying to do. It's trying to unite the absolute titans of modern physics. You've got Planck's constant from the quantum world, the speed of light from Einstein's relativity. You've got gravity in there, all wrapped up in a single compact equation. It's the ambition to write down a formula for everything.
So you see, this is so much more than just a bunch of math on a blackboard. It's really an invitation for all of us to just rethink and reassemble our entire picture of the world right from the ground up.
Which brings us to the final and maybe the most profound question of all. If the physical world and the mental world really are just two sides of the same coin, if they're described by the same fundamental mathematics, then what is the universe? Is it a giant thought just sort of unfolding across time? Is it a perfect mathematical formula playing itself out? Or is the distinction we make between a thought and a thing, is that the biggest illusion of all?